talking about pandas. We're talking about pandas series and data frame. And suffice it to say that a data frame is basically a spreadsheet, looks like a spreadsheet, like a table. And I guess many of us here we have seen how data looks like on Excel. Okay, so but then what is pandas? As this definition implies, pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool. And it is built on top of Python programming language. Okay, so but then what is pandas used for? It's mainly used for data analysis. Mainly used for data analysis. So we can say pandas is like a library, like a module built on Python programming language. So we import pandas as a package in Python to analyze data. Okay. So you can also see some of the advantages of using pandas. It is used to read various file formats like CSV, that's comma separated values, JSON objects, SQL data, Microsoft Excel, and all. It also allows various data manipulation operations such as merging, reshaping, selecting, as well as data cleaning and data wrangling. It's not like without pandas, we can't read all of these file formats, but pandas is a module, is a library, is a package that makes it easier to read than the regular way of importing using Python. Okay, so pandas is basically, it has basically two features. That's a series and the data frame. Okay, so but the main difference between the series and data frame is that the series is like two-dimensional. It has two columns with an index. It has one column with an index rather, while the data frame has more than one column. I hope that is clear. Hello, let me get it.
Yes.
Okay. Again, the main difference between the series and data frame is that the series looks more like a list.
Please go back again, please.
Okay. The series looks more like a list. It is single column. It looks more like a list, single column, while the data frame looks more like a table, more than one column. So it is multi-dimensional, the data frame. Like you get to see several columns. So since the data frame has more than one column, while series has just one column, it therefore means that we can also create a series with data frame by just specifying just single column, right? So it means that pandas data frame is widely extensively being used in the analytical world, right? Okay, so let's get to see more of this, the usage of pandas data frame. Okay, so we can see pandas data frame is a two-dimensional size, mutable, potentially heterogeneous tabular data structure with labeled axes as rows and columns. It is a two-dimensional data structure and it's also aligned in a tabular fashion in rows and columns, more like what I've already explained before. So it has just three principal components. That's the data in the table, and the rows and columns. So you get to see the importance of using these terms like rows and columns by the time we look at the shape attributes and all. Okay, so let's look at some attributes and methods that we can use in pandas data frame. I guess we have already downloaded the notebook on the Canvas dashboard, have we? I will downloaded the notebook on the Canvas dashboard.
Not yet. I'll download it now.
Please, we need to download it because we have to see the usage of some of these attributes and methods, because that's the only way we can we can harness the attributes and its usage in the real life. So I am going to switch over to the notebook now. So I'm imploring you all to get the notebook downloaded. I'm going to use the notebook and see how we can use some of these attributes and methods in Pandas while doing the extensive exploratory data analysis. Okay. So like I've already mentioned, the Pandas series and data frame, or the Pandas library in itself, is used in extensive exploratory data analysis. We used to read our files, our data. The source of the data could be Excel, could be CSV, could be Word, could be SQL database, and so many. Can also be from some of these online repositories, and also Pandas makes it easier to get them read into our notebook. Okay, so let me just switch over to the notebook. How many of us have downloaded the notebook by now? How many?
I've downloaded it.
Oh, okay, that's good. So let's follow along, please. Can you all see my screen now? Is it clear?
I'm sorry to interrupt. Dimeji, can you check your chat?
Yes, I've checked. I've seen it. Is my screen clear now?
I can see it.
Oh, okay. So like I said, a series is used to model one-dimensional data. So it looks like more like a list in regular Python. All right, so starting with trying to explore data, which could come from different sources. Like I said, the Pandas is like a library, and we need to import it into the notebook. Like we need to tell the notebook that, hey, get to see this library called Pandas. I want to use it from now on. So what you're seeing here is like a convention. It is not compulsory, but for the sake of convention, it is important. So this as here implies alias. So the name of the package, the name of the module is Numpy. The name of the module is Pandas. So we want to use this module in this notebook, but henceforth we want to be calling it PD. So that's why I was saying import Pandas as PD. So after this line, instead of calling Pandas, we'll rather be calling PD. So it is not compulsory, but it is important. Like it is important for the sake of convention, because that's the same way all programmers in the tech space, that's the same way they always call it. So you get to see the usefulness by the time we start collaborating on projects, perhaps via GitHub and all, so that there won't be conflicts. So this is how we can create a series. So you can create your own series by storing it into any variable you like. You can say, okay, let's say series PD, if that is the name of the variable you want to store your series into. Then if you want to create the series, you call on pd.series, that's pandas.series. So it takes arguments. It takes some argument like data. It takes some argument like name, index, and all. for you to know for you to see the documentation of this series, just on your keyboard, just press the Shift tab. Just press the, I think tab, no, it's not Shift tab, it's tab. Yeah. Okay, so the tab tells you, are you following? Is anyone following me? Okay. All right, so we can run this line. We can run this line, or you can also create your own series. So what I just did here is just to create an array of some numbers, like a list of numbers. So that is what is happening here. I remember Mr. Kenny has already briefly talked about Numpy before. Yes, Numpy is also a module. It is for numerical computation. And why we sometimes use it is because it is very, very fast. And some of the other libraries that we're going to be using are built upon Numpy. So you might not see yourself specifically using Numpy, as in this case, me calling it MP. But there are some other libraries that will be making use of, like Matplotlib, Seaborn, and all. All of them are built upon Numpy, such that if you don't have Numpy already installed in your machine before, calling on those modules would not work because they rely on Numpy. So I'm just using this Numpy to create a list or to create an array of numbers here, just for the sake of example. You can as well input just any other number that you want. It's because it is very, very fast in processing and all. So I just call on NP array to create an array or a list of numbers, including not a number. I believe this NaN is not new to us again. This means not a number. So can somebody give me an example of not a number? Can anyone give me an example of not a number? Like, in what situation can we have not a number? Anyone, please? Does it mean that nobody knows what not a number means? I'm waiting. I'm waiting. I want to hear our responses. What does it mean? Not a number.
I don't know what it means, and I don't understand what is going on that that B variable. I don't understand what is going on there.
Okay.
Where exactly?
Dimeji, let me come in a little bit. So sorry for interrupting. So I didn't teach NumPy, right? I don't think I've talked about NumPy, right? Yeah, so I did.
No.
So yes, so we stopped what we we didn't talk about NumPy. So obviously I expect people to be confused about that. So however, don't mind Dimeji, he assume I have. So but that not a number, we're still going to talk about it. It's just like a missing value. Like if you have a table of values, in your Excel sheet, if a particular row is missing, there's nothing there. That's what that NaN means, not a number. Is it clear?
Okay, yeah.
Yes.
Okay, so sorry, I'm not going to be using this this series now. So I'm trying to create another set of series just with a list. Okay, so I believe you understand what this means now. So I'm just creating a list of numbers. I'm supplying it into the argument data. It's part of the argument that the series takes in. Okay, so I also want to name the series. I want to put a name there, like we can put any name, let's say C or something. then that's okay for now. So let's run this line and let's see what happens. Okay, so I'm going to call it now and see. Okay, so this is an example of how a series looks like. Like I said, it has just a single column, a single column. What you have here is just the index. Is the index 0, index 1, index 2, index 3, index 4. And these are the values against each of the indices. Okay, right. I'm so sorry here. So is anyone following?
Yes.
Okay, so I think this is clear for now. Okay, so you
Yes,
can
I'm
see
following.
you can see on this line. I'll take your question. Hold on, please. So you can see on this line, the only thing I supplied into this series function is just the data and the name. I can as well remove this name. The most important thing is the data argument. Okay, can you see? So, but let me just include the name. So the name comes down there as the name of the series. All right. So by default, if you don't specify the index, it automatically attributes the index to it from zero down like that progressively from 0, 1, 2, 3. Do you understand? Okay, so but then we can as well perturb the index by imputing just anything that we want. So by calling the index attributes, you can also pass a list of index to it. But you have to make sure that the list of indices that you want to pass in must match the length of the data. What I mean is that I've already passed in a data of five numbers here. Altogether, there are 5. So if I'm specifying a list of index 2, it has to be 5. I believe I'm clear enough. So I can just say, okay, I don't want 0 to 4 again. I want A, B, C, D, and E. So let's run this. So instead of 0 to 4, it now gives me A, B, C, D. Okay, who has a question? Please go ahead with your question and let's see.
My question is, what's the difference between the name C and the variable name C? I just want to understand what is the difference.
This is the variable name. Just like you can name a table. So this is like the name of the table, but we're storing this table in a variable called C. So this C, okay, let me just change this name. Let me change this name. Let's say Samson. That's the name of a table. So the name comes here. So this is the name of our table. That is not the name of the variable. This is the name of the variable, but this is the name of our table. And the name of the table is associated with the table and not the variable, right? So this is like, oh, you want to have, this is like you are having a table, you have it in tabular format. You have this serial number colon. You also have another colon. You specify the name of the colon and all. You understand? So the name of our colon in this series is Samson. So it comes down here. But by the time we go into data frame, instead of the name coming down here, it will be on top of each of the columns, right? Because in data frame we'll have several columns, and it won't be nice just specifying the name of the column beneath it. So because this is a series and it is single columns, that's why the name is here. By the time we create a data frame, you see the name of each of the columns right there on top. You also see the name of the indices of the index here too. Any other question, please? Any question? All right, so apart from you creating a series, you can also check the type of your variable. So we have a variable C holding some data. You can check the type by invoking the type function on the variable type C. Let's see what it brings. So he's saying the type of the variable C is actually a series. I hope this is clear. And then these are some of the attributes that you can call on it. I'll tell you, you get to see the difference between an attribute and the type and a function right now. Okay, so let's call on the attribute index on our variable C, and let's see what it brings. Okay, so C dot index, let's see what it brings. So you can see saying this is the list of the index in our variable C, A, B, C, D, E. So it means once you try to run this attribute index on this variable, it's going to return the list of the index. So it is an attribute because, you know, if you want to invoke a function on a variable, the variable has to be passed into a parenthesis, like, I mean, index, they now impute the variable name inside it like this. So this is a function. A function is associated with a parenthesis, but in this case, we're not passing in any parenthesis. I also know that a method is also kind of different from a function because you apply a method on a variable by using the dot operator. So if I was supposed to, if I had input a parenthesis here like this, C dot index, open and close parenthesis, it means this index is a method on it. But now, there is no parenthesis here at all, and not even this one at all. Just the name of the attribute. So we call it an attribute. This index is an attribute. By this type is a function because we are passing the name of the variable into the function. Any question, please? Hello. Any question, please? Let me know. Let me know. Let me know if you are all following. Let me know if you are all following. I can't hear you.
I'm following and it's fine.
Yes, I'm following. I'm following.
Okay. All right. So that's one attribute that we can call on the series. We can also call on the attribute name just to see what is the name of this variable itself. So C.name returns the name of the variable. The name of the variable is actually Samson. So that's the name of our series, right? Okay. So, okay. Let's go on to, before we look at this, let's go on to creating a data frame so that you can see the similarity and differences between series and data frame. All right, don't mind me. Let's create another data frame. I know, yes, I know we have been taught the dictionary. All right, so let's use a dictionary. Let's use a dictionary to create a data frame. All right, so let's call the data frame, let's say data. Let's call the data frame data, right? Okay, so once you create a data frame, remember the last time we wanted to create a series, we called on pd.series, right? Just like in this place. So now creating a data frame, we call on pd.data frame, right? So you also supply the data using dictionary. Okay, so you know this is a dictionary because this is a curly bracket. Okay, so you pass in the name of the column first, colon, then the list of the column, the list or the data in the column, right? So like what I mean is that, let's say the name of our column would be maybe age, right? Colon. Then we want to pass in a list, not just one. If our data frame, or if the column is supposed to have just one row now, then we can just pass just maybe one value, and then put another name of another column. You understand? But now we want several rows. Let's say like 5 rows. So we're passing it as a list. All right. So you know how to pass in a list by opening square brackets. So this is just like a way to harness all of the things that we've been learning. You know, a list, you know, a dictionary. You know, for you to create a dictionary, you need to open the curly brackets. And then, you know, for you to create a list, you need to open the square brackets. So we want to pass in a list of numbers like age, let's say 20, 23, 30, 44, 22, 25. Okay, that should suffice for now. Let's say there's another column that is let's say first name. Let's say first name, and then let's say we have some other names like that. A list too. Okay, you know, a list should be name should be character, like a string. So it's supposed to be passed in between the quotation mark, right? So you can pass it in. Let's say Samson. Let's say sorry. Let's say Samson. Say Awele. What other person? Let's say Adamson, Caleb. Adamson, Caleb, Williams, right? As yes, another thing, creating a data frame, that means all of the columns you're creating must have the same number of rows. So I have 5 rows here. I have 5 data here. This other column too must have 5 data. If not, it will throw up an error. Let's see whether that is the case or not. Okay, so let me just delete this and let's see what happens. Now, this means I have 4 data in the first name column, and then I have 5. Okay, I have 5 data in the age column. I have 4 data in the first name column. Let's see what happens. Let's run this. Right, you can see the error. You can scroll down and see the error message. Arrays must all be the same length. So that means one of the columns there does not have the same length as the other. So let me complete it. All right, so now let's run it. So you can see our data frame has been successfully created. So let's call on the name of the data frame, which is data, and let's say it looks like, right? So this is the data frame. It consists of 2 columns. So you can see it looks more like a table of just 2 columns. So the same way we added just 2 columns here, you can add as much as columns as you like, right? Let me stop here. Any question for now? Any question?
Dimeji, your network is late. Like there is a delay. I don't know. Is it from my own side? You know, like most of what you've shown, it comes out when you have passed it. Am I the only one experiencing that?
No, I'm also experiencing it.
Yeah, there's a delay. There's a delay in your. Yeah. Do you get what I'm trying to say?
I got what you said, but
Yeah.
I don't know.
So, like when you got error, you passed it before you start seeing the error and all of that.
Oh, okay. Let me just run
That's
over
why
that.
it says the network. And go on. Let's hope it's going to improve.
Let me.
I can't even see. I can't see.
You can't see my screen. Who else is experiencing that?
No,
It's
I can
just
see us.
I'm also experiencing that my network is going off and on.
Yeah.
Same here, I'm also experiencing the okay too.
Okay,
Yeah,
hold
there's a
on.
delay. Mhm.
Okay, so what I'm trying to say is that the length of data in one column, in all of the columns you are passing it into the data frame must be the same. Like, for example, in this column of age here, I have 5 data. And then I'm also creating another column here, which is first name. I also have 5 data. I'm saying if, for example, you don't have 5 data here, you have 4 data instead, there will be an error. The data frame would not be successfully created. So let me just run this so that you can see it in action. So I try to create the data frame with 4 data in the first name column and 5 data in the age column. Is not working. It's throwing up an error, a value error. And then what is the message of the value error? It's saying arrays must all be the same length. So there's conflict in the length of all the columns. Can you see my screen here? Can't hear you. Can you see my screen here? You can also use the chat box.
You can see it. I can see it.
Okay, so this is what I'm trying to explain, that when you are having differences in the length of data in a data frame, and that shows that tells you that even if you are importing the data, if you are not creating the data yourself, if you are importing the data from any database, you must expect the same length of rows. You must expect the same length of rows from the source of the data. Of course, there's no mandatory, like the length of the column is not mandatory. That's just like features. But if you have 4 observations for a particular column, then you should expect the same number of observations for the rest of the columns in the data frame, right? So I believe that's clear. So any other, right? If you have a question, then you can raise up your hand. You can use the emoji, the raise hand feature and all. All right, let's see some of the other attributes that we can also apply on this data frame. Okay, so we can check the data type of each of the columns by calling on the data type on the variable D. Okay, so no, we have created a data frame here. So let's call it on it. So this is our C here. So let's call the C. There's a shortcut here. If you want to create a new cell, just click out and stay in the command. This is the command mode here. Then just press B. So it creates a cell below this. If you want a new cell above it, you just press A. If you want a new cell below it, you just press B, right? So I need a new cell here, and then I want to call on my variable C, which is a data frame. So let's see. Okay, no, it's not C, it's actually D. It's actually data. So I have my variable, I have my data frame data. Okay, so let's see. I want to call on the D types attribute on it. So that I can see the data types. Okay, so you can see it gives me the data type of each of the columns. It tells me that the data type of the age column is int 64, while the data type of the first name column is objects. Objects in the sense that we have string. Yeah, we have string in this column of first name. I hope you can see my screen. I hope you can see my screen.
Yes.
Okay, so I want to run another.
I can see your screen, sir.
I want to run another attribute on this data frame. So I click out again. I need another new cell. So I click on, I press B. It gives me a new cell. So I want to check I want to check the shape. The shape attribute actually returns the dimension of the data frame. When I say dimension, I mean what is the length of the column, what's the length of the rows. So I want to know the number of rows and number of columns. So I run the attribute shape on the data frame. So data dot shape run. So it tells me, and the format of the results is actually row by column, row by column. So this tells me that I have 5 rows and 2 columns. I have 5 rows and 2 columns. And that's actually true because we have already seen our data up here. Yeah, we have actually seen our data up here that we have 5 observations, 5 rows, 1, 2, 3, 4, 5. And then we have 2 columns. We have age column and first name column. And that corresponds to the results of this shape attribute, which is 5 row and 2 column. Is there any question, please? Please let's ask question, please.
None for now.
None for now. That's nice. Okay, please let's mute ourselves so that we can enjoy the class. Let's mute ourselves. So I'm not talking. Please mute yourself.
Dimeji, please check your chat, your private chat here.
Okay. Okay, sir. Okay. So let me also run another attribute, which is columns.
Please, can you mute others?
Chibuke, okay, thank you. Okay, so we have the columns attributes. So let's run the columns attributes. Data tells columns. Let's see the results. So it tells us the name, it returns the name of each of the columns. You get to see the usefulness of all of these attributes by the time we start exploring the data in full. Then can somebody tell me, we've talked about it before, yes. Can somebody tell me the function, or whether it's function or attributes, that will return the first 5 rows of a data frame? Anyone?
Are you talking about the head function?
Yes, exactly. So when you run the head function, on this data frame, it returns, if the data frame we're using it has more than 5 or more, many more than 5 rows or observations, the head function is going to return the first 5 rows. So let's see, head, that's head method. So I call on the data dot head. So it returns the first 5 rows. That's if, in this case, we have just 5. But if it's to be more than 5, it returns the first 5. Okay, so Mr. Kenny, please can you continue?
Okay, so let's quickly revise what Dimeji has taught so far. So the question is, why are we using pandas? Why pandas? Now, as a data analyst or a data scientist, if you're going to be working with data in rows and columns, you are going to need pandas. Okay, so pandas does not come pre-installed with your Python module. So you have to, so if you're using Jupyter Notebook like this in Anaconda, you have to import it into it, okay? So, and that's why you see the image is doing something like import pandas as PD. The PD is just a short form, like he explained. It's just like the convention. Import pandas is fine, but that would mean that I will have to keep on typing pandas. So a short name for the pandas is what you are representing PD. And pandas is about 2 things, like he explained. What are the 2 things? Anybody?
Please repeat the question.
I said pandas are about two things, like Dimeji explained. What are the two things?
Series and data frame.
Series and data frame. So just like Dimeji said, a series is just like your table, a table in Excel form. I don't mind my drawing. So like you have rows and column like this in your Excel or a table format. So suppose this is the table. Okay, so this is what we call a table in Excel or a data frame in Pandas. So a single column like this is just your series. Okay, but the collection of two or more columns is the data frame. But a single column or a single row in that table, in this table, is what we call the series. So that's why it said it's one dimensional, because it's a single column like this, or a single row. So can we say that a data frame is a collection of series? Are we going to be right by saying that?
Yes, sir.
Yes, because a series is a single column, and we said data frame has two or more columns. So that means we can say that a data frame is a collection of series. And it showed you how to create a series. So it all starts, they are all in Pandas. So that's why you import Pandas. And it told you that if you want to create, suppose you have a name called SER for the variable name standing for the series, call on your PD, put dot, you don't need to memorize, press tab. So try to scroll down to look for S, so that stands for series. Open it, and you can put your data inside. So whatever data you put, so I can create a simple data 13, 15, 16, 25. That's all. If I call SER, that gives me a series. You can see. So this is a series. And if you check the type of that to be sure, a type of SER, you will see that it's a series. Does that make sense?
Yes, sir.
So, and it also started by moving to data frame. That, okay, now for data frame, there are two concepts that I want you to take away from today's class. One is, we're going to assume that you want to create your own data frame. By data frame is like that table I just showed you, you know. So we'll first assume that you want to create your own table, your own data frame. So the question is, how do you create your own data frame? So Dimeji said that we'll quickly do an example. Then we'll end today, hopefully, by trying to suppose that someone has already created the data frame, because that's what you will see at work. And let's say you have access to the data frame, like to that table. Maybe it's online on a GitHub account or it's on your computer. How can you load it from wherever it is into your Jupyter notebook? Are the two goals clear? One is creating it from scratch. Two is it has been created, bringing it into your Jupyter notebook from wherever it is. Are those two goals clear to everybody?
Yes, sir.
Yes, sir.
All right. So let's start by saying, how do we create this data frame? So you use, like Dimeji explained, you use the concept of dictionary that we did before. Let's revise dictionary. What are the two things that makes up dictionary? In a curly bracket, you have something before the colon. In quote, you have something after the colon. What do we call the one before the colon? A key, that's correct. What about the one after the colon?
Value.
Value. You guys are smart. So let's do that. So we have a
Values.
Yeah, correct. So in this case, the key will be the column name. That was what Dimeji was trying to explain. The key will be the column name. So suppose we have a key called name, and the value in this time, let's use a list to represent the value, a list of names. Okay, so we have Fumbi here. We have Joseph. We have Awele. We have Taiwo. You know, let's just stop here. So this key will be the first column, and this will represent the rows in that column. Fumbi will be the first person on that row. Joseph will be the second, Awele the third, and Taiwo fourth. So if we want to, so if we stop here now, like this now, if we do data, if we create a data frame from it, this will be a single column. And this single column, is it still the same thing as series? Suppose I do this. I will come back to explain this. PD dot data frame. The PD dot data frame. Oh, sorry. Yeah, this is supposed to be capital. PD dot data frame and passing data. And we'll do like this. Should we still call this a series? Or
A series is a series. Right?
yeah,
Series.
because it's a single column. A single column. Now, if we now create one more column, let's say maybe we put let's say we put location, and we say okay. So let's assume Fumbi stays at Akoka, okay, and let's assume Joseph stays at maybe somewhere around maybe Ogudu, you know, and let's assume Awele stays at maybe around let's say Bariga because she works at Unilag, and let's say Taiwo stays at maybe somewhere at Yaba. So if we do this now, this becomes a data frame. Why? Anybody?
Because it has more than one column.
Exactly, because it has more than one column. So this becomes a data frame. So a single column there, if we select it, that becomes a series, and two or more columns makes up a data frame. So this is how to create a data frame in Pandas. So we've only created a data frame with 2 columns and 4 rows. And I remember the way you was trying to explain to you how you can check the dimension of your columns. We can do this, whether the data frame is small or large, we can do that. Can someone remind me how? So let's save this in a variable name called df. And come back df. So how does the manager explain how you can check the dimension? By dimension, I mean the number of rows and columns. This can be easy because you can see them. But for large something, you want to remind us.
Using the shape.
Shape.
Exactly. So this gives 4 rows, 2 columns. 4 rows. The first value stands for rows. The second stands for columns. So this means our data frame has 4 rows and 2 columns. Suppose you have many column names and you want to see them, you can actually use dot columns attributes. That will give you the column names you have in your data. So to recap, we've seen how to create a data frame from a dictionary. The key will represent the column name, the value will represent the rows. The key is the column name, the value will represent the rows. Just pass that dictionary called data to data frame method in Pandas. That's all. And you can check the number of rows and columns using the dot shape, and you can print out the column names using the dot columns. Now, let me change this. Let me make this location rep intentionally, and you can see. Now, suppose that, because we can use if you know the column name, you can use the column name to retrieve whatever data that are stored inside that column. For instance, if I want to get all the names of the people in my data, I just need to come with the data frame name dot, or use square bracket in code, passing the column name called name. This will give me all of the rows that all of the people in that column, Fumbi, Joseph, Awele, and Taiwo. And if I use location rep, also, that will give me the locations, all these ones you have. So to retrieve the information in a particular column, I've used a square bracket, put in code, and pass in the column name. There is also another method. You can use a dot method. For instance, if I put df dot, but if I'm using a dot method, I will not use a square bracket, and I will not use a quote. I can just call the name. So if I do that, that still gives me the information stored in this name column. So two things I've explained. Two ways to retrieve the information inside a particular column. One is by using a square bracket and in quotes, pass in the name of the column. And two is by using a dot method. But this dot method is limited. And I will show you how it is limited. Remember, we have used square bracket. Let's use dot. We've used dot for the name. Let's use it for the second one too. So we have location space rep, and I will get error. Why do you think this works for name and it's not working for location space rep? Anybody?
Because of the space.
Because of the space. So when you are using a dot method, you cannot use a dot method one does not permit the space. So that's why if you know you cannot rename that column that has space in between, stick to using square bracket and with quotes. If you want to use the dot method to retrieve the information in a particular column, make sure that column doesn't have a space in between its name. Are we clear so far? Is it clear?
Yes, sir.
All right. Okay, so what if we want to rename it? Oh, someone gave us that. We know the information is location. We just want to rename it to location, but we can do that. We use the rename method. So let me call this df1 just to keep the original df. So I'll call the df dot rename. So we have rename, and inside this rename, how do I even get the documentation? I showed you how to get documentation, have I? In Python, in Jupyter Notebook, how do you get the documentation of anything you want to use? I've talked about it before.
G-type.
What?
Is
Say
it
that again. Shift tab, shift tab, shift tab. Put your cursor inside the bracket of that method and press shift tab. That will give you the documentation so that you don't memorize anything. So there it tells you all of the arguments in that method. I even give examples. It gives examples of how to use it. So you want to rename, for instance, look at this one. They created a data frame called df with column name. A is the column name, capital letter A, and B is another column name. Now you want to rename this capital to small letter. You call on the rename, specify the column's argument. Where is this column coming from? Is here, it's part of the argument. See, columns. And then specify that I want to work with columns argument equals to, and inside the curly bracket, inside a dictionary, the key will be the original name, the value will be the new name, and like that. So you can do that, and you can rename multiple columns. So here I can follow the same format. I will specify the column names in curly bracket. This will be the original name, which is location space rep, colon, and this will be the new name, just location. That's all. And I can rename, if I have another column to rename, I'll just put comma, put the original name, colon, the new name. That's all. That's how you do it. So if I call df1 now, oh, I didn't close the bracket. Yeah. So I didn't close the curly bracket. So if I call df1 now, you see, it has been reflected. But df is still having the original name. I could have effected the change without assigning it to df1 by setting something here called in place. If I set in place to true, it will reflect the change in the df itself. It's going to make these changes in the df that you created, this df. But I don't encourage people to do that, because if you are setting in place to true, the original data frame will be changed. And suppose you still want to have access to the original data frame, you may not be able to do that until you restart or reload the cell where you created the data frame on. So that means you'll be switching back and forth. So the best thing, leave it as in place equals to 4. Don't touch it, just assign it to a new variable name. So is it clear on how to rename a column?
Yeah.
Is it clear?
Yes, sir.
Any question? Okay. Okay. All right. So let's see. So the second goal is how to load your own data. All right. So let me comment this guy out. So suppose the data is somewhere on my GitHub account. So I'll do that with using that. So suppose the data is somewhere on my GitHub account. So suppose the data is here. I suppose I want to use one of these data. It's on my GitHub. Okay, can you all see my screen?
Yes, sir.
All right. So suppose I want to load this sheet data. So I'll open it there. Now, if I just load it like that, I'm going to get error. You need to always click on this raw, make it a raw format. That's the one that you can load. So you can see this is the raw format because it's a comma separated values. So this is the raw format. I only need the link after clicking the raw. Let me move back. Once you click the data, you have to make sure you convert it to raw by clicking raw. Once you click to raw, so you have the data in this format. So just copy the link. So this is the link. And then let's go back to our notebook. So let's make this path and put in code. Let's put this. So that's the link to the data. Okay. And then we can load. So let's see how we can load this data using our GitHub link of the data. Note the extension. Does anybody know what CSV stands for? Anybody? Nobody. Okay. So CSV stands for comma separated values. That's why you saw these numbers separated with comma. That's what a comma separated values mean. So CSV stands for comma separated. It's more similar to your Excel, but you know your Excel can have different sheets in one in one Excel, and you can switch in between that. So, but a CSV is just a single sheet. Okay. So how can we load these comma separated values into our environment? Let's give it the name of the data called sheets. So we have imported pandas as PD. So we call PD dot. Let's press tab. Now I want to read in the data. So there should be something on read. Now look at it. As soon as I press as RE, it gave me differently. So read underscore CSV will help you to read in a CSV file. If the file is Excel, you have to use read underscore Excel. And there are other versions there. When we get to SQL and we want to read SQL data, we want to connect to our data SQL database from Python, we'll be using the read SQL query or read SQL table, things like that. And you can read a SQL file, SQL or SQL, the same name, or SPSS. I know in university, most people still use SPSS, things like that. If you have the file, SPSS, storing the data anywhere in your system, you can use this read_SPSS to read it. I'm not sure if SAS is common in Africa, but if you have a SAS file, you can use it. It's not common because it's not free. It's not open source. It's paid. You have to pay, except you do it online. So, but the most common one that you'll be using will be this CSV and Excel. So this is a CSV file because they end with .csv. So I'll just pick read_CSV and I'll pass in the path. Before I move forward, is this clear on how to, which one to choose on how to read your data? Is it clear or any question?
It is.
All right. So this, if I call on this now, this will load the data for me. You can see it loads the data. So we are picking it from my GitHub and we are loading it. So that's why all you need is the link, and that makes it easy to work with data anywhere. So just ask for the link. Oh, you want me to work with other data? Can I have the link to the data? Once you are given the link, sorry, can you be, if you have a question, you can ask. If not,
I have a question, sir.
Yeah, please don't interrupt.
Since we are using an HTTP website stuff, sir, does it require connection, data connection?
Yes, you have to be connected online. If you are not connected online, because HTTP is on a site, there's no way you can read it in. That's a good question, but please don't interrupt. I will always allow you to ask questions. Yeah, so because it's HTTP, like it's online, the data is somewhere online, this you have to be connected. But if the data is on your desktop, it's not going to be in HTTP, and that means you don't need internet. I will do that one too, like pick it from my local computer and then we'll read it. Okay, so this is how to do that. So suppose the data is on my local computer. So let's go, let me see, I think I can find one. So in this, suppose I want to load this data, Gapminder here, this Gapminder stuff. So it's a TXT file, it's a text document. However, this text document is separated with commas. So it's still a comma separated value, but placed in a text document. So because I know it's still comma separated values in a text document, I can still load it with read CSV. So I just need to get this path. I just need to get it. And then come here. Let's say I put in URL. And then this is gapminder.txt. Now, if I go ahead and load this directly, I'll get error, and I'll tell you why. So let's put this as gap. So I have pd dot press tab, read CSV. I'm using CSV because I know the content in this Gapminder as comma separated values. So suppose I put my URL this way. This will give me error. And this is, the reason this is giving me error is that Windows, if you're using Windows system, you're going to have, when you copy a file, it's going to be separated with backslashes. And so Python is reacting to those backslashes. So two things. It's either you change all the backslash there, all the backslash is there to /, or you put R here standing for, you are saying this is a raw string. R stands for raw. So you are saying, don't worry about the backslash. This is just a raw string. If I do this now, I will not get error. You see? And I can check it. I can check whatever is in the gap. You see? I have it loaded. Any question? Am I too fast? I need your response.
No, sir. No, sir.
All right. Please don't be shy to ask questions. Okay. So, but in most times you are not going to be displaying everything. You know, as even though I try to display it, Jupyter Notebook is so smart that you realize that if I'm to display this data is about 10,000 rows. If I'm to display this data, the whole screen will be filled up. And you have access to this data. I hope you know. Go to your go to your Canvas. I think this is your dashboard. Yeah, so you have some data here. See all the zip folder, class data, flight, Olympic exercise. Unzip them, wine quality. There's so much data for you to play around, tidy data, download them and unzip them, put them on your computer. You're going to be using them, okay? So there are so many, even those you are not using, play around them, just use them to practice, okay? So you have access to them and you can use them for even for any, if you are still in school, you're working on, but I don't know what you're working on, you can use them, okay? We give you, okay? Don't need to take permission from me. All right, okay. So part of inside the data, inside one of the data, I'm sure is inside that class data, you should have access to this Gapminder, okay? So as much as Jupyter Notebook try to, after displaying the first 5, you can see put ... and then give me the last 5, telling me that data inside, but I cannot display everything. So what you mostly do is to display the first 5. Do you know how to do that? The first 5 rows.
.add object.
.add. So use the .add method. So that gives the first 5 rows. So the reason you quickly do that is to just check if your data were loaded properly. That's the major thing. So you just check, and we can check the last few rows to gap dot. That will be dot what? Hello. Dot tail. So we do that. So that gives the last 5 rows. Don't worry about this. That's not a number. We will still get to how to deal with them. Okay. Don't worry about them for now. What I want you to catch throughout today is how to create your own data and how to load your data. Suppose you are working, whether you are currently working as an administrator, in a particular organization, or you're already working, or you are planning to work as a data analyst, this will help you. If you're already working, let's just say as an administrator, and you are given Excel or CSV data to be working with, this will really help you. One, you should be able to get the link from wherever it is. If you're on Windows, remember to put R before it, or turn the / to /. Read it in if it's a CSV file. If it's an Excel file, we will use the read _ Excel. And if it has multiple sheets, is either you specify, I will get to that, I can explain if you have questions that we can. Just specify the sheet you want to load, or you can load the multiple sheets like that. So you can check the first 5 rows and the last 5 rows. Okay? So that's the major, and we can also check the dimension, just like the major already taught you. We can use the same concept .shape. That will give us the number of rows and number of columns. We can see here, we have about 10,111 rows and 8 columns. So we can also, if you want to manually get the column names, you can do .columns. .columns is an attribute that will give all the columns in the data. all the columns, country, year, fertility, life, and all of that. We can also, if we want to get the whole information at a go, we can do that. We can use the info method, standing for information, info method. So that gives the info, all of the information at a go. It tells us that you have 10,111 entries that stand for rows, starting from 0 to 10,110. It tells us the columns you have, that the first one is country, year is second, fertility, and like that. Region is the last one. And it tells us we have 8 of them. That's starting from 0 to 7, 8 columns. It tells us how many rows are not missing in each of the country. How many rows does it have that NaN? Don't worry about NaN, just know that it stands for something. It's an indication that some rows are missing, that there are no values in some rows are missing. So this is giving you the number of rows that are not missing. That's why you are saying non-null. Null stands for NaN, like not something missing. So you can see this one is missing like 11. It says out of the 10,111, 10,100 is not missing. This one out of 10,108 is not missing. This one has so much missing values. So you only have 9,210 that are not missing, like that. So you can use this to do your analysis. Some of you do analysis. So when you get your data, this info will help you do analysis, and you can start writing your report, things like that, like the number of rows, number of columns, the column names. In so column, there are some, these are the number of rows missing. These are the number of rows not missing, things like that. You can use the info method to do that. Any questions so far? Or is it clear to everybody?
It's clear, sir.
All right, thank you. Please, if you have questions, feel free to ask. Now, I'm not sure if you will be able to get to exercise today, except, I'm not sure, except you are not just going to do any calculations on like that. So, but today is just to familiarize you with it. And from tomorrow, from next week, we can start doing interesting stuff. Because if you don't know how to load in your data, that will be problematic. Okay, so other things you can do, we can also manually check, automatically check how many columns, how many rows are actually missing in each of these columns. Like this, we only know fertility has some NaN, and this is only giving us, I start to do, okay, 10,100, 10,111. So, you have to start subtracting and all of that. But you can save yourself the stress of making that mistakes and do it. Pandas help us to automatically get how many rows are missing in each of these columns. So call the column name, the data frame, and press tab. When you want to ask a question, you start with is. So under the is, we have is NA, we have is null. Let me use is NA, both works the same thing. If I just say is NA, this is going to go through each column and go through each row in each column. You can see instead of writing a loop, if you want to write a for loop here now, your code will be long. You will have to loop through each column, and in each column, you will have to check in each row. Now, you have to loop through each row. So this is like double for loop. We have to first loop like for things like this. This will be more complicated, like for call in gap.columns. So this will pick the column name. So this will pick the first column. I will now loop again, like, okay, in this column, for I, maybe in each row in the columns, if I is not equals to maybe empty quotes, then something like that. Maybe you should save it somewhere. So the code will be complicated if you are writing for loop now to check the column the row that is missing or count it, things like that. We can, and I can do that, but that's a lot of stuff, and that's why Pandas is there. So if I do this now, this will go through each column and will go through each row in each column and ask, is this row NA, is this row missing? If it's missing, if it's NA, it's going to put true. And if it's not missing, it's going to put false. That's what you see here. Very fast, instead of writing bogus code. Now, this might not be so meaningful. Now, in Python, Booleans, true and false. False is treated as 0, true is treated as 1. So if false is treated as 0 and true is treated as 1, if I had all the false in each row, since they are treated as 0, it's like 0 plus 0 plus 0, and when you see true equal 1 plus 1, that can give me the sum of the rows that is missing in that column. So I just need to add dot sum. So I'm adding dot sum to sum all the rows in each column. That's all I'm doing. So if I do that, this tells me no row is missing in country, no row is missing in year. 11, which is the same as this. 11 rows are missing in fertility, 3 in population, you can see, and then 1,011 in GDP, 91 like that. So this can explicitly help you do that. I don't know if this is clear or I'm moving too fast, just what do you think? Is it clear? People are not talking again. You're tired. Sorry. Is it clear?
Yes, sir.
Okay, thank you, Rafiu. So that's that on. So what you are basically taking out is today is creating your data frame or how to load in your data and do some basic exploration. These are the few things you quickly do anytime you lay your hands on data. Check the dimensions, the number of rows and columns, check the first 5 rows, check the last 5 rows, check the column name, check the info method to quickly get a view of what is going on in the data or the comprehensive information about the data. Check if there is missing values using this is na.sum. And the final thing you can check is also to see a descriptive statistics about your data. And by descriptive statistics, I mean you can check or you can try to get the mean, the average of the numeric columns, the mean, the median, the minimum value, the maximum value in each column. You can quickly do that. So if I do gap dot press tab, put D, we have a describe method that will do that for us. So the describe, we describe each column. Like you have in the year, is going to describe in each column, like the count of the rows, the average year, average fertility, average life expectancy, average population like that, the standard deviation, the minimum year there. So that means this data stands from 1964 to 2013. The minimum fertility is 0.83, things like that. And you can use this to analyze the data. 25% for those who did a little bit statistics, it stands for the lower quartile. That is the first 25% of your data. And the 75% stands for the first 75% of your data, the upper quartile or the last 25%. And the 50% is the median. So you get a brief, but what do you observe about this describe? Does it include all the columns? Does it? What do you observe? Anybody? Are these all the columns we have in the data? People are not talking. What columns are missing? What
No,
columns
sir.
are missing?
I think it includes only the columns that have integer numbers.
Thank you, Awele. That's
Like
very correct. Very correct. It only pick the columns that are numeric, only the quantitative, yes. No, all these one that have objects that contains words like country and region, they are missing there. That's because pandas feel that it doesn't make sense. How can I get mean of country? Like, what's the average country? That's not a good question. That's not a relevant question. How can you calculate average of countries? What do you mean? Do you mean average of their GDP? You mean average of their population, but not just average of country names? That doesn't make sense. But if you still want to get it, you can. But by default, Describe will only give you the descriptive statistics of the numeric columns, the quantitative columns in your data. But if you want to get everything, put your cursor in that and press Shift tab. There is this include that you are going to specify. So if I specify include to be all, include to be all, it's going to give me everything. But now some doesn't make sense. Now look at country. It can only give you the unique number of rows, the unique rows, but the count of all the rows and the top row, maybe the one that have the top count is Italy, things like that. But others, you can see any, because you can't get the mean, the average of country, things like that. You can't get that. And you can see for region, the same thing, everything. But for the numeric, for mean up to GDP, from year to that, it gives you the mean, the standard deviation, all of that. So by default, include will not include everything. I mean, the Describe will not include everything, except you specify the include to be all. So that's the basic, that's the most thing. So I don't want to go deep, like, because of the time, I don't want to pick the log, high log, group by. I can make that next week. But so if I've not done that, I'm not sure you can answer this question. The only thing you might be able to do is to load your data. So I want you to practice on your own. Pick one of the data on your system. I've given you the data there on your Canvas dashboard. Load them. See if you can load them into your Jupyter Notebook in Anaconda. Practice. If you have a GitHub account, you can also upload them to your GitHub. I've shown you how to upload something on your GitHub. Practice loading it from there, or also practice loading it from your local computer, maybe on your desktop, and then do this simple exploration, like the first 5 rows, the last 5 rows, the check the descriptive statistics, the column names, the info method, the dimensions of do all of that. Once you are confident with that, all other ones like selecting, we'll get to that from next week by God's grace. Does it make sense? Do you have some other things you can do is, suppose this is our data. I mean, let's see. So this is our data. Remember, we can check the first 5 rows. So let's say I want to select, I showed you how to select a single column using the column name like this. Like I've shown you how to do this. Suppose I want to put fertility there. I've shown you how to do that. You already know how to do it. But suppose you want to select multiple columns. What do you think I can do? Like I want to select fertility and population. What do you think I would do? Anybody? Yes.
When you put in a comma, work for it.
Okay. So I'll put population. Oof, error. Why?
Yeah.
He said, no. Okay, who can help out? You have the right idea, but you were missing out something. Fumbi, I've not heard your voice today. Yes? What do you think? Any idea? Joseph? Awele, do you have an idea?
I thought comma would work too, but French is not working.
Okay, so now you want to select multiple. Just say, so this is a list. So let's put all these lists in and wrap it around another, this. Let's just put, we're putting a whole list inside this square bracket. This will work. So what's the message? If you are selecting more than one single, if you are selecting more than one column, you have to put them in a list, but so that means you are using double square brackets. Double. So meaning I'm putting all the column names, all the column I want to select in a list and dumping it inside a list, square bracket. Then that will be. So this can select any different numbers. You can select 3 or, but it's going to be in the order at which you select. So let me select country as last now. This will switch there. It's going to be in the order at which you select them, even though the order may not tally with what you had before. It's going to follow the order at which you select it. That's all. You get, so just use double square brackets. So that's how to select multiple. But next week, I will show you a better way using the loc and high loc. Because this one now, what if I don't want, this is giving me all of the rows. What if I just want the first 20 rows of these 3 columns? First 20 rows for these 3 columns. What do you think we can do? Anybody? Yes, Adamson. What do you think? Yakub.
I have no idea.
I have no idea, sir.
Okay, our lady have an idea.
No idea, sir.
Okay, so let's put another square bracket and put colon 20. Does this work? Remember we did list and we did indexing in list. Remember, we did something like this. Do you remember? We did something like
Yes,
this.
sir. Yes, sir.
Yeah, so that's the same idea. Select the entire data frame and then put in quotes, it's a square bracket and put colon 20. That will give the first 20. What if I want between 10 and 20? See, it works. You specify the beginning and the different and the ending. Remember, the same thing, it doesn't include that 20. That's it. Yeah. So that's the same way. But there is a better way, and I will do that next week by God's grace, using the loc and high loc. But I will explain that. But this is also doing similar thing. Okay, so we are selecting. If we don't put this square bracket, it's going to select all of the rows for these 3 columns. If we want to select maybe from let's say from 500 to the end, we just put 500 colon, and this will select from 500 to the end of the data frame. We did all of this indexing at the beginning. You can see how the understanding of that, of list, indexing list or strings, how it's working here too. You can do that here too. So everything you've learned before there is not a waste. Everything there is not a waste. So you can do that. So this will select everything starting from 500 to the end. And like I showed you, you can select the starting point to the ending point. So we can end here. At least it's a good place to end. And then where we will start will be, after revising all this next, we will start from an alternative to this indexing, retrieving your rows using loc and iloc. And then we'll move to group by to start doing some calculations, start asking questions on our data, and then using pandas to answer those questions. And then you'll be able to do a lot of, I will add to, before next week, I will add a lot of exercise here with different data. So next week will be a lot of exercise. So make sure you don't miss it. Make sure you don't miss it. It will be a lot of exercise since we are not able to do one today. Is today, I hope you learned something today. I hope you are able to go back with something. Okay?
Yes, sir.
All right.
Yes,
So
sir.
yeah, so we can stop here.